Hello. I believe this is the seventh video in Conditional Probability chapter. So we are going to start a new example. Now imagine that you are the quality control manager of a smartphone factory, right? So in particular, you as a manager, you are concerned about like defective batteries. You receive batteries from suppliers, battery producers, but some of them are defective. As a result, your smartphone may not function well in the future. So you would like to analyze the battery problems and the probability about defects. And first, as a like quality control manager, you know that there are two battery suppliers. There are two suppliers. One is a domestic supplier, and the other is a foreign supplier. And you receive batteries from two like producers, two suppliers, and their ratio is given this way. So 60% of batteries are coming from the domestic uh, factories, and 40% are coming from foreign factories. And so based on this situation, we will define like two basic events again. It's like 2 by 2 example again. D stands for domestic suppliers. Domestic supplier. Actually, it's confusing because D may stand for defect, but please understand. Now, D is for domestic, and F is for defect. So, batteries you use for your production can be classified into four categories based on where it's from and whether it is defective or not. So it's 2 by 2 case, right? And additionally, on important information is this. So I said there are two supplies, and depending on the source of the supply, the defective rate can be different. So domestic factories make 2% of defective batteries, right? And foreign factories make 7% of defective batteries, right? You understand? Like the sentences are straightforward. You know what I'm saying, what the sentences, what this information tells you. Now, again, the important part is this. Express the information in terms of statistics. Try to connect the conditional probability concepts to this information, how you may translate the information to conditional probabilities. Again, F stands for defect, D stands for domestic, right? Defect is F, domestic is D. Okay, then, so think about this sentence. 2% of domestic batteries are defective. So if you choose 100 batteries, on average, 2 of them are going to be defective. Then, that means it's the main event of interest is defect. By the way, the condition is domestic batteries. So that means you are choosing 100 batteries from domestic suppliers, right? So that's the condition you already imposed. You know that those 100 batteries are from domestic suppliers, and then if you inspect them, 2 of them are defective. So the condition is D, and the main event is F. So the first sentence can be written as this way, C or E. And then the other sentence, 7%. Now what we are going to do is we choose 100 batteries, and those batteries are imported. Randomly choose 100 imported batteries, and then 7 of them are going to be defective. So D complement stands for imported batteries, D complement, and F is defect. So the main event is the same, but the condition is different. So the answer is C, right? Like this is the most important part, and like how you should be able to translate the information you understand into statistics. And so this is the example. C is the answer, right? So as I said, you may rewrite this probability this way. We are calculating the probability of defect given that, think about what is the condition given that a battery is domestic or a battery is imported. So given a certain condition, what is the main event? That's the structure of conditional probability. And then, so the information as a manager again, the information you have are these numbers, 2%, 7% defect rates, and the ratio of suppliers, how much proportion of suppliers among your batteries. That's all information you have. And then in the end, what you care about is this. What is the overall defect rate? You understand that one supplier has 2% defect, the other has 7% defect. But in the end, what is yours? What is the defect rate for your final product? And also, you may wonder, among the defective batteries, how many of them are domestically supplied? How many of them are imported? Like so then as you can see, our goal is first, like our information is given in terms of conditional probabilities. But from the conditional probabilities, you would like to calculate on unconditional probability. That's one thing. And this is like the conditional probability takes this form, F given D. But what you want here is the other conditional probability, D given F. How can you switch the role of event and condition? So that is what we are going to do. We are going like starting from the conditional probabilities and calculate other unknown probabilities. And in the end, our goal is the simplest way, like most fundamental way to answer those questions is that to recover the full probability distribution table. This was our starting point in the earlier part of this chapter. If we know the full probability distribution, we know how to calculate any probability, right? That's what we have learned so far. But the problem in this example is that we don't have those numbers. So we are going to set this as an intermediate goal. We will recover the probability distribution table, and then once you have the table, it's straightforward, right? So that's our plan, how we are going to proceed to handle these problems, to tackle these problems. Okay. So I'm going to give you an interesting, like I'll show you an interesting method, which is often called like tree diagram method. But it's like it sounds like elementary school level diagram, right? Actually, right. Like so, let's think about this. In our what we are going to do is we will imagine like an imaginary kind of data, like, and we will classify them. So we will, in our imagination, we are going to choose a certain number, randomly choose a certain number of observations, and then we will classify those observations using the probabilities given in that information, right? So it's hard to explain without example. So let's start that process. First, I'm going to imagine 100 batteries. 100 batteries will be inspected. So I'm going to randomly choose, 1,000 1,000 batteries. So imagine you chose 1,000 batteries. They are in front of you. And then, based on the information available, you know 60% of them are domestic and the other 40% are imported. So classify 1,000 batteries into two piles. One pile has 600 domestic batteries, and the other pile has 400 imported batteries, right? Right, of course, everything is in our imagination. So 1,000 products are classified into two piles. And then from the first pile, like domestic batteries, we know that given domestic batteries under this condition, 2% is the defect rate. That is, like in front of us, we have 600 domestic batteries in this pile, and among 600, 2% is 12. So you can pull out 12 defective batteries from the pile and make another pile. So as you can see, 600 domestic batteries can be divided again into 12 defective batteries and the other 588 non-defective batteries, right? So we have two piles in the end on this side. And now we are moving to the imported battery pile. There are in this pile there are 400 imported batteries, and their defect rate is different. It's 7%. Their defect rate is 7%. So 7% of 400 batteries will be 28. So among 400 imported batteries, 28 are defective. So pull them out, make another pile. And then again, in the end, we have two piles from the imported batteries. So that is 28 imported and defective batteries. And finally, 372 imported and non-defective batteries. Right? So, it's pretty straightforward, like imaginary experiment, right? You don't need to start from 1,000. You may use 10,000. You may use 500. But of course, easier number. Like I chose 1,000 because this is a simple number. We'll make the results simple numbers. But it doesn't matter. No matter what you use, does not matter at all. And also, what you have to realize here is you have to apply the correct probability in the correct order. The first, out of the total batteries, 1,000 batteries, you have to apply the unconditional probability first because there is no condition at the beginning. And once you classify the batteries into subcategories, and then in each subcategory, they share one condition, right? So then you use conditional probability based on that condition, right? So here in this pile, you have to apply domestic defect rate, and on the other pile, you have to apply foreign defect rate, import defect rate, right? So then, in the end, you classified 1,000 into 4 different categories, which will be 2 by 2 table, frequency table. Like you can think it as a kind of data with 1,000 observations, and we classify them into 4 different types, 4 different outcomes. So you have all the information you need. Now, try this. Think about this. Based on those numbers, can you calculate the probability of defective batteries? What is the probability of defective batteries based on those imaginary experiment? Okay, I'm going to give you the answer in the following video. So see you there. Try this question first and then start the next one after you finish your question.